The diagram shows the path of a ball in absence of a resistance. Q is the highest point and A is the vertical acceleration at Q. At impact, the velocity makes an angle theta to the horizontal. Three statements about the actual motion of the ball when there is a resistance are: Q is lower, A remains the same, and theta increases. Which statement are correct? First of all, about the force of a resistance. It always opposes motion and it's proportional to the velocity. And the path when there is a resistance looks like this. And definitely, since there is additional force which opposes motion, the highest point will be lower. So Q is lower, definitely it's correct. And what about the acceleration at the highest point? It's very important that it's not at any arbitrary chosen point, but it's the highest point. At the highest point, it's the vertical component of the velocity is 0, and force of air resistance is proportional to the velocity, and hence vertical. It's only vertical component of the force of air resistance is 0. So at the highest point, with or without a resistance, in vertical components only, it will be absolutely the same. And acceleration, it will be acceleration due to gravity only. It's actually g, so it's also a. I repeat that in general, if we consider in vertical direction, there is what mg, and when it is moving up, there is additional force due to resistance. And without a resistance, there is mg only, and second Newton's law, without its mg is ma, and in general, when there is a resistance, it's F plus mg is equal to ma, but at the highest point, velocity is 0, and this F is proportional to v, or maybe v squared, but it doesn't matter. But it appears that this force is equal to 0, and there is mg only, so it's also mg is ma, so acceleration is equal to g, so a remains the same. And what about theta? It seems that velocity vector is at tangent to the trajectory, and it seems that tangent at this point will be more vertical, and I can suggest that theta increases. So I choose D. And that's all for this question.